Aha, graph paper. Now, I'm going to take an ordered pair here, and we're going to talk about what is called the distance formula. So I'm going to write that up here. The distance formula. And let me go ahead and I'll take some pretty colors here. I'm going to take blue, I think. And I'm going to take the ordered pair, -3, 5. Where is that thing? It would be in the second quadrant, wouldn't it? -3, 5 is right here. So I'm just going to label that ordered pair. So this is quadrant 2, if you remember from chapter 3. I'll sneak a little exam review in there. And then I will pick a point in the fourth quadrant just to scare y'all. How about 7, -1? And I'm just making these numbers, these points up here. I could pick any 2 points on the graph. And let's just connect them with a little line segment here. Now the distance formula is going to allow us to calculate the distance between these 2 points. And here's what the formula looks like. Okay, D, and this is a big, long, scary formula here, so let me write it here. So D equals the square root of, excuse me, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And you may have remembered some of these subscripts from chapter 3 when we were finding the slopes of lines and writing equations of lines and graphing and stuff. And remember when we did that, I always told y'all to make sure you label your points here. So we're going to label the points, and let me take a nice pretty red here. I'm going to call this point x1, y1, and I'm going to call this point x2, y2. And it doesn't matter which one you call x1, y1, and x2, y2. But now all we're going to do to get this distance here is plug in those values. Now, why we didn't do this when we were graphing in chapter 3 is we didn't know about these fun radicals yet. See, and they're going to want us to get a radical answer and then simplify that in section 7.3. So let's go ahead and plug it in here. So the distance is going to equal the square root of x2 is 7 minus x1 is -3. And oh, I can see people making sign errors there. Be careful with those signs. They cut like a knife. Plus y2 would be -1 minus y1 is -5 squared. So this will give me the square root, simplifying, -7 minus -3 in that first parentheses would be 10 squared. I'll put a little parentheses around that, plus -6 squared, which would give me the square root of 100 plus 36, which would be the square root of 136. So that would be the distance. Now, of course, we could go ahead on our calculators and we can approximate the square root of 136. I'm just going to go ahead and get my calculator here and do that. Now, my calculator says it's about 11.661903, and it goes out there a long way. So I'd say it's about 11.7 if I were going to estimate that. Let me write that over here. About 11.7 of those little distance, those little dots there between each little dot. Okay. Now, can we simplify the square root of 136? Let's take our perfect square numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. I don't think any of those numbers go into 136 evenly. So they would consider this answer at the square root of 136 simplified radical form. So a little example of where you use radicals in real life would be to find the distance between 2 points using this distance formula. Radicals are measured that way.